We're going on now to topic 4 of chapter 4, absolute value equations and inequalities. Notice we are on page 293 in our textbook. We just have one more section after this to complete our Math 100 course. So we're going to be dealing with these things, and we're going to take a look, thinking about way back in the beginning when we talked about section 2 of chapter 1 and what absolute value means. Again, it's vertical lines to either side of something in the middle. Here it's x, and we're saying the absolute value of x. Now, whatever it is that we have inside the absolute sign, it is always positive because it's the counting distance that something is from 0, and these are always positive. So to do some easy examples, we have the absolute value of x equals 4. That's an equation. The absolute value of x equals 0. And the absolute value of x is a -7. So what possible answers or values can you have inside there that would make this statement true? Well, it could have been a -4, or it could have been a +4. So that's what we need to do when we are dealing with absolute value equations. As you write it, the absolute value of something will always be positive, but what could have been the value of x to give you that? Well, in something like this, it's just it could have been a -4. That would give you a +4 or a +4. Now, since 0, the only value of 0 is 0, this one is a 0. Now, in letter C, this is a little tricky because didn't we just say that the absolute value of something is always positive? So for something like this, there is no solution because that cannot be true. Okay? So again, in your textbook, the answers are given there. Now, one of the things you're going to find, and I'm just going to give you a thumbs up on this. Now, I've made a little graph, and suppose we have the equation, and we're going to have some of this later, but I wanted you to see this, that you have y equals the absolute value of x. Well, in a sense, we could think of that as y equals x, or y equals a -x. So I've set up some points where y equals 0, and of course that's just going to be 0. And now the absolute value of x, let's suppose there's a 1. Well, that's going to be a 1. Suppose it's a -1. Well, the absolute value of x is always the same, so a -1 is 1. Here we have 2, that's going to be 2. Absolute value of -2 is 2. So we're going to graph this now. Well, 0, 0 is right here. There's a 1, 1, which will be right there. Now this is a -1, 1, which is going to be right there. And this is a 2, 2, which is right there. And this is a -2 right there. So if you see what's happening here, we're going to have a line that looks like so, and a line that looks like so. So when we see a graph that looks like this, This is an absolute value graph. Okay? I'm off a little bit there, but you get the idea. So I wanted you to see sort of what's going on, and let's continue. Okay, I think that's that page there. Now, they want us to solve this equation, for example 2. So, what's going on here? Well, again, we have some basic procedural things that we need to do. And the way we do it is we write the statement without the absolute signs. That's the first one. We just take away the absolute signs. Or, again, we take away the absolute signs and we say that could have been a negative 5. Now we solve these equations. So this one is going to be x transpose the negative 3, that becomes an 8. X transpose the negative 3, that becomes a positive 3. This is going to be a negative 2. So there is your answer set. Okay? Now, they do give you some things here. If we were to graph that, and again, if you put this in, if this were an equation, y equals the absolute value of x minus 3, and you make the graph that we did before, the only thing difference is that this negative 3, if you recall from an earlier lesson, we say shifts to over here. That you might think it would be over there, but it's opposite sign, and it's right there. So it's the same graph that I just sketched for you, except we shift it over. When it's a negative 3, we shift it over to a positive 3. Now, we're saying here that this is going to equal either a 5 or a negative 5. And that's what they're showing you right here. Well, there's the negative 2 over there. I guess they're showing it to us here. And then there's the 8 right there. Okay, so this you would pick up on a graphing calculator. And again, we're not featuring the graphing calculator, but I wanted you to see how it related. It's actually an important part. Let's continue. So our solution set of that we said was this. So there's the basic rule, the absolute value principle of equations. You take away the absolute sign, you have it equal whatever's there. Take away the absolute sign and you have it equal the opposite. That's how it's done when you have an equation that is an equal sign there. Let's go on. Okay. Now for example 3, they want us to do this one, A. We'll look at it in a moment. But they also want us to do this one. And what do you see already here? Can an absolute value ever be equal to a negative? when it's still with its absolute signs? And the answer is no. So there's no answer for this one, no solution. So for this one, that first one there, we're going to plug in. I usually do it the other way. Take away the absolute sign, and it's equal to 13. Here they're doing take away the absolute sign, and it's equal to its opposite, a negative 13. So you can do it either way. And then they're just simple equations, and there are your answers. Now, when you graph this, again, I don't know how much graphing we're going to be doing, but basically we have 2x plus 5, and if that is equal to 0, when we graph it, remember this is sort of like y equals this, we're going to shift it over 1, 2, 3, 4, 5 units, and our slope here is going to be over 1 up 2, so it'll shift it up a little bit, and so it's a little more steep. Let me see if I can get a good line going here. And then you run through and say y equals 13, which gives you this line right over here. And you see our roots then are a negative 9 right there and a positive 4 right there. So there's the graph of letter A. And again, we're not asking you to graph yet. We're just showing you if we did graph it, what it would look like. And that one's okay. But then when we did this other one, we said there was no solution because the absolute value of something cannot equal a negative 8. By the way, where is negative 8 on this graph? So you could graph this part, but the negative 8 is way down here, and there's no intersection of these. Okay, so let's continue. Okay, now for this one, they're giving you this function notation where it's in this particular form, and part is to interpret what's going on. So this is what the function is, and they're saying find all x's for which y, in a sense, equals 15. So we want to have that as our y over here, but our x is this. This is going to equal 15. That's the key of how to put this into a form that we can work. Okay, so what's the first thing we do? Well, let's clear it up first. And we have this 1 here that we have to transpose to the other side. So we want to isolate our absolute sign. So we subtract 1 from both sides, we get 14. Now we have this 2 outside the absolute sign. But if I divide both sides by 2, Here I get rid of it, and here I get 7. So now I have what I should start with in a sense, or as we move along. And we have the absolute value of x plus 3 equals 7. So again, the way I would do it, you remove the absolute signs, or x plus 3 equals a negative 7. Now they do it the other way, but again, whichever way you're comfortable with is fine. So here we're going to get x equals, subtract 3, 4. And here we're going to get x equals, subtract 3, you get a negative 10. So your solution set then is a negative 10 or a positive 4. And if you were to graph this, again, this is an absolute value graph where y is 15. There's y equals 15 is a horizontal line going through 15. Then your x values here is a negative 10 and here a positive 4. So again, we're tying it into graphing, but basically this is where we are working on this side, and it checks out. Now, I guess basically in this section we're going to be doing, I think we went ahead too much there. Let's go back. I must have hit something. Here we go. Again, we want to develop a strategy for solving these. So we're going to go x minus 2 equals 3, or x minus 2 equals a negative 3. We're saying this would equal a positive value. This would equal a negative value. So we just go to solve it. X equals, transpose that, becomes a 5. X equals, transpose that. Again, it's a positive 2 and a negative 3 becomes a negative 1. So there are your answers. Now, when we graph that, and that's what they're asking us to do now, what will that look like? Well, on a number line, this equation has a dot at negative 1, which is one of our answers, and a dot at positive 5. And in a sense, we are 2 units away from 0 here. So there's where our 3 units are, because we shifted that, remember. If this is y equals x minus 2, when that is grafted, if that were to be our equation, there's a dotted 2 and a line goes up this way and this way. Again, we're going to just stick here with what they're asking. And they're showing it as a graph there. That's fine. Okay, now, how about example 6? Well, again, we're reading the textbook, and I'm giving you an overview of the textbook. But we want strategy, and perhaps my giving you a little lesson on it is helpful. When you have something like this, where there's 2 absolute signs, the way it works is, our first equation would be, just remove the absolute signs, 2x minus 3 equals x plus 5. That would be one set of equations. Then we would go or. Again, our second equation starts 2x minus 3, where we're taking away the absolute signs. But now we put a negative in front of what's in that parenthesis, x plus 5. So we're saying the opposite of what is there. So what will this one become? Well, it's going to be 2x minus 3 equals a negative x and a negative 5. And then we solve it. Okay? So let's raise it up because it is worked out here. And they did it this time just removing the absolute signs, and we get x equals 8. Now here they had a negative sign in front of what was the absolute value. We're reversing the signs. This becomes a negative. This becomes a negative. We're going to add 3 to both sides, and then this one is a fraction. So there are your solutions for when both are in absolute signs. Again, the protocol, remove them both. That's your first set of equations. Then the second set, remove the absolute signs, but put parentheses and a negative sign in front of the parentheses. Then get rid of the parentheses by changing these signs and then solving it. Okay? And you could plot that on a number line if you like. And this is what it would look like in a graph. But again, we're not doing graphing. So I'm not going to feature that right now. Okay, let's go on. Okay, now we're taking a look at what are called inequalities as absolute values. And this is sort of interesting. So, what goes on here? Well, basically, it's going to become, again, we write it just like this, that x is less than 4. Just take away the absolute sign. And x now, we're going to reverse that absolute sign from less than to greater than, and then opposite sign there. Now, if we were to graph this, what would we end up with? Well, let me make a little graph over here. Now it says x is less than 4. So we're going to have a parenthesis here at 4. And the line is going to go this way. And we're also saying x is greater than negative 4. So x is going to be in the middle here. And this is negative 4. And we're saying x is greater than. So in a sense, what do you have here? Well, when you have the absolute value of x and it's less than a number, you have actually, and I happen to put and here, you have an intersection. This is where we talked about this in the previous section, and this is going to be in interval notation, negative 4, comma 4, and in set builder notation, x is such that negative 4 is less than x, x is less than 4. And in a sense, it should be an old friend now. Now, this is true when you have the absolute value of something is less than. You get a conjunction. Let's go on. Now, here we have something a little different. Again, it's the absolute value of x, but now instead of being less than, they're saying x is greater than or equal to 4. So again, you would write it just this way: x is greater or equal to 4, or x is less than or equal to negative 4. Notice I had to reverse the inequality sign as I did this. Now we have done these already. So how do you graph it? Well, you're going to put a bracket at negative 4 facing this way, a bracket at positive 4 facing this way. This is a disjunction. And notice how you write it in set builder notation, how you write it in interval notation. We've done these already. And how it looks in a graph. Okay? All right, so here are some principles for solving absolute value problems. We had said when you have the absolute value of something and it's equal, you have one that's just like this. Just remove the absolute sign, then remove the absolute sign and use its opposite. And the graphing looks like this. Now, if you have an inequality that's less than, this is going to end up looking as a conjunction, and the set builder notation will look a little bit like this. And if you have it greater than, it's going to be a disjunction. So if you need this, and I think most probably would, and notice they have this written up on the side here too. Very good. Take some notes on this. Now the tape is running a little long, so we're going to keep moving along here. Now, these are solved pretty much the same way as we did with regular inequality equations. Here, this will be, oh, and by the way, let's say the above principles are true for any positive number p. If p is negative, any value of x will satisfy the inequality, this, because absolute value is never negative. Thus, when you see something like this, that the absolute value of something that's greater than negative 3 is true for any real number, and the solution set is all real numbers. Now this is a little tricky in here, where they're saying the absolute value is greater than negative 3, and again they're saying that because the absolute value of something is never negative, that's a little tricky. If p is not positive, then the inequality absolute value is less than p has no solution. So the key here is, as long as it says it's greater than something negative, that's all real numbers. But if it says it's less than a negative 3, this one as no solution. So whether you're going to remember this or not, I would strongly advise that you write this rule down, because that's a little tricky there. We were saying absolute values can never be equal to a negative, but they're defining it as if it's greater than a negative. That is true for all real numbers. But if it's less than a negative, that is the one in absolute value that has no solution. All right, that is a little tricky. Okay, let's go and solve example 9 here. So this is going to be straightforward, and I'll do it for you up here. So 3x minus 2 is less than 4, or 3x minus 2 is greater than negative 4. And they have this worked out for you down here. Now, even though I wrote the word or there, actually this is an and, because this is a conjunction, because it's less than. We had said that if things were less than, this was a conjunction. I should have used the word and. And if it's greater than, then we're going to use the word or. That would be a disjunction. Okay, again, you can read this over, trying to keep the tape a little bit short, and watching your inequality signs here. Since they're both less than, it's going to be parentheses, and they do the graph. And for this one, now they're saying when this absolute value is greater than or equal to 6, this is where you will have a disjunction. And they're doing them right here, and they're using the right letters. Remember, this will be equal to a negative 6 or a positive 6. And when you get your solution, which is what they have right here, and you graph it and then show it in interval notation. Notice, anytime your inequality sign is greater than, absolute value is greater than, you're going to get a disjunction. And I think we've gone over enough examples, although they're giving us more. And there's the graphical approach that we're going to skip. Okay, so it's going into our review. And again, it's available in the book if you want to read it. We've ran this about 34 minutes, so we'll close it up.